After we have done the interaction analysis, we go to the final step, which is called as function modeling. Now is where we will start to identify which function is not working well, because of which the problem is appearing. Okay. So function modeling is the stage in function analysis where a function model of the analyzed system is built. And the function model describes the functions, their usefulness, performance level, and costs at the system and the super system components. So we're talking about functions, why they are important. Are these functions happening or being done at the level that is desired? And what is the cost of getting these functions happening in the first place? Because unless you know about the costs, if you propose a solution, that solution may not really work, because you propose a solution which increase the cost of the entire super system or of the engineering system 5 times. So there is a solution, but that's not really a solution. People will not pay 5 times the money to solve a problem, probably, unless that problem is actually the main parameter of value. Are you able to see this? Why all the 4 things are important?
Yes.
So Pranay is asking, is this useful in software applications also? Yes. In software applications, for example, you may have one function, second function. So over there you have these modules that you may have defined, and those modules are interacting amongst each other. And you realize that your software is running slow because of 1 or 2 of those interactions between those modules. Are you able to see this, Pranay? So this analysis can also be done on the software systems. It is not restricted to only mechanical or electrical systems there. Okay. Now, what is a function? We say that in the function modeling part, we will identify all the functions in a system. So what is a function? A function is an action performed by one component to change or maintain a parameter of another component. For example, flame, one component, heats burgers. So what parameter of the burgers has the flame changed? The temperature. So flame heats burgers is a function, where flame, which is the actor, is called function carrier, and burgers would be object of the function, the component whose parameter has been modified or maintained. Okay. So conditions for existence of a function, as we already discussed, that they should have an interaction. And if we are talking of a function in an engineering system, the function carrier and the object both should be components of the engineering system. So first, function carrier and object are components of the engineering system, and then function carrier interacts with the object of the function. Unless this happens, there is no function happening. So, and third is that some parameter of the object of the function should either change or be maintained as a result of that interaction. So these 3 conditions have to be met to say that there is a function there. If any of these 3 conditions is not met, then you say there is no function. Okay. So, for example, hammer moves the nail. What is the function carrier over here? What is the function carrier over here?
It's a hammer.
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 What is the object of the function?
Nail.
A nail.
Nail.
And what parameter has changed?
Position.
Pressure.
Position of the nail has changed. So some parameter has also changed. So this is a valid function. Okay. Now, what is the function of an open door?
To let anyone in.
You should let anyone enter the room.
To let a child enter the room. So what is the function carrier over here?
Door.
So the hinges.
Hinges. Okay. Or door. Okay. What is the object of the function? Huh? People. The child. Huh? So is there an interaction happening? Is the child touching the hinge?
No. If it is open.
If it is not open, then he has to.
Yeah. But as of now, the child is not touching the hinge nor the door. So can there be a function here? So an open door does not have any function. A closed door has a function. So you said to allow a person, and they are not nothing. There's no function between the open door and the running person because there is no interaction between them. Okay. Are you able to see this?
Yes.
Now, what is the function of a helmet? This is a soldier wearing a helmet, and there is someone attacking the soldier. So what is the function of a helmet?
So to prevent
protect.
head injury.
So what is the function carrier?
So in case of soldiers, maybe.
Huh? Helmet is the
So the
function
material
carrier.
of the.
So helmet is the function carrier. What is the object of the function?
Head.
The head of the soldier. Huh? So what parameter of the head has changed?
Safety.
So it's maintained. The safety is maintained of the head.
Safety is enhanced.
So when you define functions in your engineering systems, how will you define safety is enhanced? Is there a metric of safety is enhanced? Is there a number you can give? No. So when you define such a function, it will not help you in any way. So when we talk of function modeling, we never define declarative functions. We never say that to protect the head, to save the soldier, to provide safety. No. We never say this. What we say is the function is to deflect or to stop the bullet. Do you see this? Because when you say to provide safety, now what, as an engineer, what would you work on it? Can you do anything about it? Agar safety nahi mili to? No. But when you define a function like to deflect a bullet, now you can do something about it. Oh, it did not stop the bullet. Now, why did it not stop the bullet? Now you can do something about it. But to save the soldier, oh, the helmet could not save the soldier. That's a declarative statement. As an engineer, it does not take you anywhere. So such declarative statements for functions are not allowed. Okay. Some parameter has to be changed or retained or maintained. Over here, the parameter is one, the direction of the bullet has changed, or the velocity of the bullet has changed. Okay. So this is the next set of rules for defining functions. The first is interaction should happen So those three rules should be met. They have to be components of the system or super system. Then we said there has to be an interaction. So open door has no function to perform. Then we said that we do not use declarative statements. Safety, protection, cleaning, all that, no. What is the function of a toothbrush? So there are these dirty teeth of a dinosaur. What does a toothbrush do? Sorry, I could not understand, Anuj. There was a crackling sound when you were speaking.
To wash it.
To wash it. Okay. Wash what is the object of the
Cleaning.
function? Cleaning. Abhi maine kaha ki we don't use declarative. So what is the object of this cleaning?
So scrubbing, can we say, like?
So scrubbing is an action. What is
To remove the dirt or germs.
Yeah, to remove the dirt, to kill the bacteria, to remove germs. They are the right functions. I'm so happy. To clean teeth, to brighten teeth, nothing. The teeth look brighter because the plaque has been removed. The teeth are clean because I've removed the germs and plaque from it. To prevent cavities, all these are declarative statements. We cannot use them. We simply say to remove plaque, to remove food. That is what leads to all these, is it not? And if this is not happening well, you can do something about it. If you simply say a declarative statement, this toothbrush does not clean my teeth properly. Now, as an engineer, how would you solve the problem? Can you solve it? No. So that function, you can say it. It is English language. You can say it. But in an engineering term, it does not help us. So we do not use such declarative statements as functions. Okay. So we do not use negative formulations. We do not use declarative formulations, and we should be as specific as possible. If we cannot think of what parameter is changing, you can simply say X changes Y parameter of Z. Okay. And importantly, we document only consequential functions. For example, we say air cools coffee, not coffee heats the air. So when you are a customer, or when you are designing or making coffee, so you want to, or when you are delivering pizzas to the homes of your customers, you do not want lots of air to interact with your pizza because it would cool the pizza. So you have those bags in which the pizza delivery boy brings those pizzas to you. He's reduced the air contact. So it was a relevant function for which a solution was found. Now, pizzas were heating the air. Is that a relevant function? Do you want to find a solution to it? No. But imagine you were given the task of air conditioning the Domino's outlet. Then something heating the air. Will that be a relevant function?
Yeah.
Yes. So whether a function is consequential or inconsequential is very significantly dependent on what is the context, what is the problem that we are trying to solve. Okay. So I think let's stop here, and we will start from here tomorrow. And tomorrow we will then review, we will use the component analysis, the interaction analysis, and putting these functions in, we will also start to work on our problem that we have identified. So those teams who have not yet identified a problem, or who thought that they had identified a product but have not really done that yet, who were in a very vague state, कि हम suggestions देंगे. So please, I would suggest meet today, identify, zero in on the product, so that tomorrow when we start to do function analysis, function modeling of your system, you have the relevant inputs. Okay. Any questions? So Shana, we started the class at 1:30. We have had 1.5 hour class.
Oh, sorry, sir. I thought it started at 2:30. I joined late.
Okay. Okay, so we will start from here tomorrow.
सर
Yes.
सर ऑफिस और कब है सर ये
At
CIP
3:30 onwards. My office hours are from 3:30 onwards.
सेम लिंक ना सर
There is a separate Google Meet link that I have posted on the classroom. We will meet there.
ओके सर
Okay.
थैंक यू सर